All right, here we go. So 2.1, parallel lines, transversals, and angle pairs. Now, this is really, I broke down two lessons into, one big lesson into two. So this is the first half. 2.2 goes with this. They build on each other. So don't start getting crazy about, there's not a lot of math here is what I'm trying to say. The objective here is that you will be able to identify relationships between lines and planes that do not intersect. Now, that's our first thing. We're going to identify some relationships. Then we're going to learn to name angles formed by lines in a transversal. And we're not talking about parallel lines. We're just talking about two lines cut by another line. There's a list of vocabulary words here that I can barely see, and I apologize for that. This is plainer, I think, on when I put it on Google Classroom. And then there's some defined terms. Now, the difference between a defined term and an undefined term, a defined term, I can put it out there and it's true every case, okay? An undefined term is like a point. If I talk about a point on the coordinate plane, and then I look at my classroom from the floor to the ceiling, how many possible planes could be there besides the ceiling, which is a plane, and the floor, which is a plane? Okay, so I got all these infinite number of possible planes in there. If I just put a dot out in the middle of the room, then I could identify it with the back wall plane, the front wall plane, the ceiling, the floor, the right, the left, and any thickness. It doesn't have a thickness. So that's why some terms are called undefined, because they can just be located anywhere. We just call them on a piece of paper. That's what this is. This plane that's drawn here, it's just to let you know that we're talking about, what if I laid down a piece of paper and drew two lines on it? What would make something parallel? They have to be on the same plane. They have to be coplanar. They also have to never intersect. And then there's this little symbol thing. Right here it is. It says that AB is parallel to CD. That's the symbol for parallel. Two little lines. And that's important, because I'm not going to write the word parallel out every time I want to say something is parallel. I don't expect you to either. Just like I don't expect you to write the word perpendicular, and I've already been over it at one point. But remember, that little upside down T means perpendicular. So, little slashes for parallelism. Here's another definition of skew lines. They are not coplanar, they are not parallel, and they do not intersect. So, in this picture, these two lines are on the plane, and this line right here, I'm going to color it in. This line right here is going through the plane, but it intersects this line at point A. So those two lines are not skew. They're just on a different plane because they intersect. If I come over here off this plane and draw this line right here, that's a skew line. And we'll talk about that more when we get into the shapes in a minute. Okay, and then the last thing talks about two parallel planes are planes that do not intersect. So if you think about the side of a box, like the left and the right, the front and the back, the bottom and the top of a box, those are parallel planes. You'd have three pairs of parallel planes on a box. And there's the only thing here is that it uses that same symbol, and then we have to write out the word plane because we don't have a shortcut for that. Okay. On to the vocabulary for this lesson. Now, underneath each vocabulary concept, I put some words for the word bank. And we have 3 words on the front, and then a couple of example problems, and a 4th word on the back of that we're going to do definitions for. So let's start with parallel lines. Now, we are talking about lines here. So this is parallel lines they have to be coplanar. They have to be on the same plane. I can't talk about a line on this tabletop and a line on that back wall. I can't do that. They have to be on the same plane. And they never intersect. Now, these 2 lines are marked to be parallel. I'm going to highlight this is an arrow head. Looks like a little arrowhead, whatever. On there, that arrow is used to indicate that 2 lines are parallel. So if I had another set of lines in this same picture that went like this, and I wanted to say, oh, well, those 2 lines are parallel, so I would need to put at least a pair of arrowheads, because I don't want people thinking that these 2 lines are parallel to those 2 that I already had. Obvious that they're not, right? So these 2 lines are parallel, these 2 lines are parallel. If I had a 3rd set of lines in the figure, it would have a 3rd arrowhead on it to say this is only parallel to that one that's got 3 on it. Okay, the symbolic notation there is this slash though, right? And I would write this as line AB. Line AB is parallel to line CD. Alright, we're going to just keep going. Parallel planes. So, the floor and the ceiling in my classroom are parallel. The front wall and the back wall are parallel. Sorry. When you walk in the door, the left-hand wall and the right-hand wall are parallel. So, if you want to think of my classroom as a box, that's a good thing. Think of it as, okay? A box. And so I have parallel planes are planes that never intersect. And this is a J and that is a K. Make it a little plainer. So that would be like that picture. That's like the top and the bottom of a box without the sides drawn on it. You know, that's all that is. That little dashed part just shows me that that is behind J. So it's like 2 pieces of paper slid in parallel to each other. The symbolic notation here for this is really the same as what we talked about up front, except I don't have a shortcut for plane, so I have to say plane J is parallel to plane K. This would be like top and bottom of the classroom. Tabletop, floor, if you want to look at it that way. Top of the box, bottom of the box, if you want to look at it that way. Alright, this last one, this is hard for kids to get, and I need you to understand that it all has to do with where they're located, but it's about skew lines. Now, we've learned all about parallel lines, and the one thing that we said up here is they are coplanar. So that means they're on the same plane, right? Every time. They have to be on the same plane. Skew lines are non-coplanar, and they never intersect. Okay, so what I have here is a paperclip box. And it has a top, and of course it has a bottom, and then it has 4 sides. They're all a little different, except the 2 ends are the same. Anyway, if I look at this paperclip box and I talk about something being skew, I could talk about this back top edge of this box and this front up and down corner of the box. Now, if I look at that with pencils, I'm just going to use some colored pencils here. I can stand up my orange pencil along this front corner and lay my red pencil along that top back corner, side, edge, whatever you want to call it. Those 2 guys would never cross each other. They're also not in the same plane. Is this pencil line anywhere near this pencil line, the red one? They're not in the same plane. Now, if I looked like this, you know, those are on this. That's a plane. That's a plane of this box. But this front edge, this line here, and this top back red line, those are not planes. So when I ask you to name what is a non-coplanar line that never intersects, it can't be on the same plane. So let's look at the back of the box is WYRS. Okay? Let's just start there with the back of the box. I'm going to try to color in the back of the box a light yellow so you'll know that's the back there. What is never going to intersect the back of the box? T to P, see that right here? U to Q. Never going to intersect the back of the box. How about, what if I talk about T over to V, this line right here, and P to Q right there? Anything else? Can you think of anything that will not intersect the back of the box? Is it okay for something to go through the box? Like this picture up here? It's okay, but if it touches this line, it's got a point that's coplanar. Everybody okay with that? Those 2 examples? That's really all that's all I'm gonna give you. Because that, if you can understand that these 4 points never touch the back of the box, you'll be fine on this. Okay? So, let's roll on to the next page. And I'm going to go over this example 1, and then you're going to do example 2. Alright, example 1 says, name all the segments that are parallel to AE. I'm going to do this one in red. I'm going to highlight AE. And everything that's parallel to it would be H to D, right? H to D. How about F to B? Both of those are coplanar to AE. What about GC? Is it parallel? Yes. Alright. Part B says give 2 examples of parallel planes. Well, let's stick with the top of the box. E, H, G, and F. E, H, G, and F. That's the top of the box. How would I name the bottom of the box? A, D, C, and B. And then we could do the front of the box, right? Let's start here. This is the back. This was the top. This was the bottom. Let's talk about the front of the box. If I want to name it, I'm going to go AEFB. AEFB. Could I have went ABFE? Yes. I mean, it doesn't matter. Could I start it at a different letter? Yes. And then the back of the box, see if you can name it on your paper. Doesn't matter where you start. Even though I started with A here, I don't have to go back here and start with D. And really those are planes, and I only technically need 3 letters to name a plane. Okay? I feel like it's best if you pull all 4 letters off and hold it in your brain so that if you're trying to match it to an answer on something, you've got that. But you only need 3. And it says name all segments skew to GH. Let's start right here. That's G and H. That's on the top and the back of the box. So when I talk about segments that are skewed to that, I have to talk about F to B and E to A. I don't really want to talk about F to H because it's on the same plane as the top of the box. But I can come down here and talk about A over to B. And that's enough. If you can name 2 or 3 that are never going to touch that line, not parallel to that line, not on the same side anywhere as that side, you're good. Edge. I guess that's another word for it. Edge. Right? Okay. This is a little harder, but pause your video right here and try that problem.